Okay, the next topic we want to look at is vector subtraction. That is specifically how to subtract vectors graphically. Now we've already had a hint of what this means, but we want to see how to do it in general with any two vectors regardless of what magnitude they are or what direction they're pointing in. Now, when you're talking about doing graphical vector subtraction, there are actually two different methods by which you can do vector subtraction. And the first method, and the one we're going to start looking at, is simply adding a negative vector. In other words, if I look at the equation a minus b, what that really means is a plus a negative b. And as we've already seen, negative b simply means take your vector b and flip it 180 degrees. So if we flip our vector b by 180 degrees, we get minus b. Now, just a quick note here, you want to make sure that when you do that, you label it properly, because if you flip a vector, it's no longer b, it's negative b, or whatever letter is representing it. So let's just jump right in and look at a couple of vectors here. Now I've got these two vectors that I want to look at, r and s, and I want to form the vector subtraction r minus s. So I'm looking to form r vector minus s vector. And so we know that in order to do that, we're going to form r minus s is equal to r plus negative s. How do we get negative s? Well, we can see it right here. It's simply s flipped upside down, or specifically flipped 180 degrees. Now we can do our regular vector addition. And so if I choose tail to tip twice, and of course I could do the parallelogram method too, and you probably ought to practice that on your own just to make sure that you understand it, but we'll just do the tail to tip twice method here. And so if you look at the vector down below, I've got r here, I've got minus s connected tail to tip, and then I go from the tail of r to the tip of s to form the sum r plus negative s, or simply r minus s. That gives me that vector subtraction. Now we want to look at an alternative method for doing vector subtraction. Now this method is a little bit more tricky, but it's also more useful. And so the steps are this. First, we're going to connect the two vectors together tail to tail. And that means they're going to have a common starting point. Very important, do not flip the second vector. In the previous method for vector subtraction, we were adding a negative, and so we had to flip that second vector. Here, we're connecting the original two vectors tail to tail. Now, we can immediately, once we have them connected tail to tail, we can draw the vector difference from the tip of the second to the tip of the first. And again, when we mean second, we mean the one after the minus sign. So, a useful mnemonic to remember the order: subtract second to first to get two tips. In other words, we're going to go from the second to the first. So, for example, over here I've drawn in a minus b. Remember, b is the second and a is the first. And so we go second to the first from the tip to the tip. Let's actually do it, and I think it'll make more sense. So here I have my same two vectors, r and s, but instead of flipping s upside down, I've connected it to r with a common origin so that they are connected tail to tail. That's the first step. Now, I want to go from s to r. Remember, you go from the second to the first, and you go from tip to tip. So from the second, which is s, to the first, which is r, I draw the straight line r minus s, and that is my vector subtraction. Now, so we have two methods: the method where we add the negative, and the method where we connect them tail to tail and draw from tip to tip. It's important that you are able to do both of these methods. The first method, the adding the negative, that's actually, in my opinion, the easier way to do it. But this second method, we're going to see later on, is actually the more useful of the two methods. So if I was given a problem, if you just gave me two vectors on a test, two arrows to draw representing two vectors, and you said form, a minus b or q minus p or whatever two vectors you want me to subtract, if I were doing this on a test, if I were given two vectors, A and B, and I was expected to draw the vector subtraction, I would do the first method. I would actually flip the second and do the normal vector addition. The adding the negative would be my way of doing it because I think it's easier and you're much less likely to make a mistake. However, what we're going to see is time and time again when we're analyzing physical systems and we're looking at how the vectors work in the real world, this second method of vector subtraction where you have them connected tail to tail, that is going to be the method that is easiest to see what's going on and the one that's going to be more useful to us. So it's worth spending the time to learn both those techniques. So just to recap, let's compare these two techniques. So if I have my original two vectors here, I've got my r vector and my s vector. The first method is to add a negative. So I've flipped my s upside down, I've drawn my r, I've gone tail to tip. Here's my second tail to tip, and that gives me my r minus s. The other method is to not flip the s, but to connect the two vectors tail to tail and go from the second to the first, and that lets me draw my vector subtraction. Now let's look at these two purple vectors here. I've got this one up above and this one down below. You can see they're the same length and the same direction. That's because they're both the same vector, r minus s. So regardless of which of these two methods you try, you're going to get the same answer. And that's very important. I'm also going to give you a couple of warnings here, and I'm a little bit hesitant to even mention them because I don't want them to stick in your head so that you do them by mistake. But I've noticed in teaching this topic for many years that my students make some very common mistakes over and over again, and I just wanted to highlight those so that you could avoid them. So when you want to do vector subtraction, the biggest mistake I see my students do is they mix up the two methods. In other words, they want to do the second method, but they flip the vector. And you can't do that because that will give you the wrong answer. So you have to keep these two approaches straight. And so if you're not clear on that, go back and watch this video again, take notes, make sure it's clear which way is the first method and which way is the second method, because you don't want to mix them up. Now, really, it's a little bit extra confusing because we've got two methods of adding vectors and we've got two methods of subtracting vectors, and it's very easy to basically mix up whether you're subtracting or which method of subtracting you're doing or whether you're adding. And so the only way to get this straight in your head is to practice, lots and lots of practice. Because I can guarantee you that on your first test, there's going to be a problem where I give you two arrows and I say, add these two vectors or subtract them or do something, some kind of manipulation with them, and you have to understand how to do that. So please practice this until you keep it straight in your head, because this should be free and easy points on a test.